Hello, welcome back to Outmouth Labs. My name is Penny, and I'm glad you're here. We are continuing on with our Pixel Falls adventure game series, so this is going to be episode 4. A lot to talk about today. We've made a lot of changes. So we can start with taking a quick look at those changes. You'll immediately see that we have enemies, as well as a new type of coin, which is a gem, and buttons and traps. So finally, if we hit the Z button, we now also fire arrows in 4 directions that destroy themselves after 48 pixels. 2 shots from our arrows wipes out an enemy. If we step on a trap, we get hit, and then we have a grace period before we can take more damage. We hit the button, the traps go away and are no longer a danger. If we touch an enemy, we also lose a heart. Just like before, we have the same camera setup. If we... If we get our coins and our key, we can now open that door. The key works differently, although similar to the coins, so we have the flexibility of making pickups do different things depending on what they are. Once we open up our door, once we hit 20 coins, it automatically gives us another heart and resets the coins to 0. So all of that works well. The only other thing to show you is if we collect, say, some coins and we say kill a monster, we're making our way through the level, but then we take full damage, it resets the level, as well as our coin count and the enemies. Okay, so it's a lot to go over. Let's start taking a look. Obviously, we started by drawing out our additional features, such as our gems. Our gems are made up of 6 frames to get that sort of sparkle effect. Our button is 2 frames, our arrow is 2 frames, and our enemy is 3 frames. So we drew everything out. Next up, we went into our code editor and we created nodes for our arrow, enemy, spike switch, and spike floor, and gem. So all of these are nodes. Starting to take a look, we'll just start with gem because it's right there. It's extremely similar to coin. It has a name, gem, a sprite, a current frame, a frame timer, a frame speed, and its spin animation. The reason 37 is repeated so many times is I wanted it to take a little bit before it sparkles again. So we just have it go through the same frame over and over again, which to the player's point of view is no change. We then run our animate function, just like before, and we draw to self.sprite just like before. Nothing different there from a coin, except that it gives you more gold when you pick it up. Why does it give you more gold when you pick it up? Well, if you go over to our player function, or our player code, rather, and we look at our, find it for us. There we go, collect. We have coin, which gives you self.coins plus 1. We now have, if the collider's name is gem, self.coins plus 5. We just added another else if to our chain. That simple. Next up, let's take a look at the spike floor. The spike floor has a X and Y and a sprite, and it's drawn. That's it. In addition, if we go to our settings, we notice that it is a trap tag. Remember, tags are set in the game settings and are an enum, which you can then drop down in the code editor. Our gems and coins, just as a reminder, have the tag collectible. That's for doing the collision, which is tells our collect or take damage or any of those other functions to fire. Okay? Next up, we have our spike switch. Our spike switch is looking for a collision. If it collides with the player, so an object with the tag player, it changes its sprite from 22 to 23, which means it's been pushed. We then go through and look at from I equals 1 to the length of the spikes table, take whatever spike we're on, so spike 1, spike 2, spike 3, etc., and change it to 7, which is the disabled looking picture, and then we're going to turn their colliders enabled to false, which literally turns off their colliders. Remember, you use a colon and not a dot for Lua when you are accessing a method of a class, or technically the method of a table. So just remember colon whenever self is involved. Okay, then we draw it out. So it is set to go. If the player touches it, it changes what it looks like, and it deactivates the spikes. Very simple. Next up, we have our arrow. Our arrow is a little bit more complex. The arrow, of course, has a name, has a location, has a sprite. It also has a flip X and flip Y, which we use so that we can draw two arrows and get all four directions. If flip X is enabled, the arrow is pointed left. If flip Y is enabled, the arrow is pointed up. Otherwise, it's pointed right and down, respectively. We give it a speed. It's twice as fast as the player is. We go ahead and give it a table with directions so that we don't have to remember that up equals 1. We can just say directions.up, and that's equal to the value 1. It's easier. You can not do it. You can just do 1, 2, 3, 4, but I like to do this because I have a bad memory. We're then going to set the direction of our arrow by default to directions right, and it changes depending on the player's input. We then create a variable or a attribute called origin X and origin Y, which is set to the X and Y when the arrow comes into existence. We need that to do the math to make it the arrow destroy itself after 48 pixels. Finally, we set its Z value to 10,000. Because this is a node, its Z value is important. The higher the Z value, the closer to the camera, if you will, it's being displayed. So by setting it to 10,000, it's very unlikely that anything will ever be ahead of the arrow, so you can always see the arrow flying. Next up, in the update function, we check the direction. If the direction is, for instance, to the right, we tell it to self.x to go plus equal to speed. And then we say if self.x minus self.origin is greater than or equal to 32, I guess it's 32, not 48 pixels, then destroy self. For the left, if the direction is left, we want self.x to minus equal to speed. And if self.origin is minus self.x is greater than 32, then we destroy. Now in the y, it's the same thing. If it's up, self.y minus self.speed. If the origin minus self.y is 32, destroy. And finally down, which is the positive direction, self.y plus equals self.speed. If self.y minus self.origin y is greater than or equal to 32, then destroy self. If you have any questions about this math, feel free to put it in the comments, but basically we're setting the point it comes into existence and counting out 32 pixels in whatever direction we fired it, and at that 32 pixel mark, the arrow blows itself up. This is done for several reasons. One, it makes a little bit more challenge, so you can't sit on one side of the level and just shoot everything from across the level. But also, if we didn't have the arrow destroy itself, eventually you would have potentially hundreds or even thousands of arrows just floating off in the digital space, and each one of those takes up a little memory. It would eventually cause memory errors. Okay, then we say damage enemy, so it's always looking to see if it's hit an enemy. What is damage enemy? Well, we say if the arrow has collided with a node with the tag enemy, then capture that collider. So local colliders equals get collided entities that hit the arrow self. We determine that the target is colliders 1. So the first thing it hit becomes the target. We take the target's HP, minus equal 1. And then we say if the target's HP is less than or equal to 0, destroy the target. And then no matter what, destroy yourself. So the arrow is destroyed. And then we draw everything. Notice that we have gone all the way through. So this is draw the sprite at self X, self Y, that it is 8 pixels wide, because 1 and 1, these are map coordinates. Remember, and our map coordinates are 8 by 8. So 8 pixels wide, 8 pixels tall, and whatever we've set flip X and flip Y to, which is determined by the direction. Okay. Hopefully that all makes sense. All right, so we keep saying that it's determined by the direction. How are we actually getting that direction? Well, if we go over to player, notice that player has self.directions as well now. It's exactly the same. And it also has a self.dir now, which is, again, exactly the same. If we go down to our move code, we say if you hit key right, self.dir is equal to self-directions.right. So the player's direction is equal to the same number that is right for both the player and the arrow. So great. When we then fire our arrow, which we do by, I can show you that code as well. Who's at the very bottom? Yeah. With fire arrow, if the button pressed key Z, so if we hit the Z key, if the player's direction is equal to, say, up, then we spawn an arrow at the player's X, the player's Y, with a sprite of 25, which is the arrow pointing down. We don't change the flip X, but we do change the flip Y. So now it's pointed up, and we send the direction of the player to the arrow. So the arrow now knows it is pointed up and needs to go up 32 pixels. That's the magic. So when we spawn our arrow, we send all the data it needs to know which way it's pointed, where it's going, for how long. And we can do this for all 4 directions. We can also use this code with very little change to give, say, monsters a fireball or any other projectile. This is very flexible bullet code. Okay. Finally, we go to our enemy. These enemies are about as simple as they get. They have a name, an HP, a sprite. They have the animation required attributes. They have an origin, X and Y, and a speed, which is 0.5. We animate them just like we've been animating everything else, and we tell them to start moving off at their speed in the right-hand direction. Once they collide with any wall, their speed multiplies by -1, so it becomes the opposite. If they're happily stepping along to the right at 0.5, now they'll be happily stepping along to the left at 0.5, and they just go back and forth. You can get a lot more advanced with AI, and we will eventually, but this gets our guys moving with an HP, and whenever they connect with the player takes damage. Why does the player take damage? The player takes damage because in the player code, if we look at trap collide, if self has collided with any object with the tag trap, and they're not already hurt, which is how we create the grace period, then they take damage. If we go down to take damage, their HP goes down by 1. If their HP is less than or equal to 0, then we reset. Otherwise, the hurt reset timer goes to 0, and they become hurt. If they're hurt but not dead, which we know because they're hurt, but they have not reset, self.hurt reset plus equal 1, meaning that the timer that we've created goes up by 1 every frame. If that hurt reset divided by 10 has no remainder, then we're going to flip the player's visibility to make them blink. If the hurt reset is greater than or equal to 90, so after 90 frames, hurt will go to false, the hurt reset timer will go to 0, and the player will be damageable again. Ultimately, we'll also add a sound effect. We want to make sure the player knows they're being hurt. Okay, so that is all of the new code. And you're starting to see how these things go together. So if you're not used to object-oriented programming, this is all object-oriented programming, or as close as we can get. And the idea being, we create code that can be used on different game objects in different ways that talk to each other, and that we can reuse that code so that all objects, for instance, can fire arrows, even if an enemy arrow looks like a fireball or looks like a bullet, whatever. So hopefully this is all starting to make sense. Hopefully this is helpful. Let me know if you have any questions. We're going to keep on keeping on. And happy game making. Take care.